Okay.
See you in a week?
9-7.
Dude!
Oh my
God! England con!
He went to saw the Newsies in England.
Yes, I'm aware.
So we were wondering if the Jack had a British accent.
Probably.
You just said.
Alright,
I'm winning brains.
I'm being bullied.
Here, 9-14.
You're involved on. Bring it up on yourself.
So we have theorem 914. It says if two chords intersect in a circle, then the products of the measures of the segments of the chords are equal. Wow. Sounds like a mouthful. So here we are. If we have here, that's a chord AB, and then here, let's go with CD. Okay, two chords intersect in a circle. It then says the product of the measures. Okay, the products of the measures of the segments of the chords are equal. Okay, so all it refers to is this. You have segments. If AB is your chord, you have this segment. Let's give it A, B, C, D. Give it another letter E. What it's stating then is AE times BE equals DE times CE. So it simply just takes the segments, multiplies them together, segments multiplied together, and those are equal. That's all that theorem
Wait, are
is.
they congruent chords?
Nope, don't have to be congruent chords. So chords don't have to be congruent. Good question, but they don't have to be congruent.
Wait, is this talking about the angle, like the angle measure or the length?
Nope. Angle measure would have an angle symbol. It's the segments of the chords.
So what does this do?
The segment of the chord, like this segment times this segment, is equal to this segment times this segment. So if you're given two chords and in there, and you know part of this and part, you know this and this and this, but not this, we can figure out what that is.
Super easy.
So 9:15, if two secant segments are drawn to a circle from an exterior point, so here's your exterior point, and two secant segments are drawn like this, okay? If two secant segments are drawn to a circle from an exterior point, then the product of the measures of one secant segment is, and its external secant segment is equal to the product of the measures of the other secant segment and its external segment. So it sounds again like a mouthful, but we'll break it down. A, B, C, and then we'll call this D and E. Use the same letters. Okay, so we have two secants from the exterior. And it says the product of the measures of one secant segment and its external secant segment. So what's the secant segment? The secant segment would be AC. So AC is the whole secant segment. And it says its product, so we have to multiply it by something, and then its external, which would be AB. So AC times AB, okay, is equal to the other one, AE times AD. Now Nicholas asked on 914, theorem 914, it says, do the chords have to be equal? No, they don't. The same is true with this. This chord, or excuse me, this secant doesn't need to be equal to that secant. They're not, that's not part of the theorem. It's just two secants drawn from the same exterior point. So don't have to be equal. Alright, and then 916 is a tangent segment and a secant segment. So let's go like this. Tangency, what does tangent mean?
So it's like
Intersects in
the outside.
one spot. Intersects in one spot, yeah. So kind of on the outside, kind of on the inside, but neither. It's just intersecting in one spot, yeah. Secant means what? I should have asked that. Intersects in two spots. A chord, review,
Inside.
endpoints are on the circle, right? Endpoints are on the circle. Okay, so this says if a tangent and a secant are drawn from an exterior point, so there we go, we'll call this A, we'll call this, that's the tangent right there, B, it doesn't go on, and then we'll call that C and D, there we go. it says the square of the measure of the tangent segment. So the square, so AB squared equals the product of the measure of the secant segment and its external secant segment. So the same thing as what we were doing before over here, AD times AC. The hardest part for this chapter is to remember all of your rules. So I just gave you 3 new theorems, right? And you're like, what happens when I have this and this, and this and that? And when, if you recall, like Zeke was asking about angle measures. Remember, you had rules that said, hey, if you have this, then the angle measured here was equal to the, wasn't it half the difference of this minus this, if you recall? That was a while back, over a week ago, but that was a rule. That was talking about angle measures. Now we're talking about the lengths of the secants and things like that. So you have to remember all of these rules as you practice them. Hopefully you'll remember which ones would correlate to which problems. So let's do a few problems here with some unknowns. Find the value of x. Find x, and we'll go with number 1 here. That is an atrocious circle, but we'll trash. Okay, thank you.
What does that mean?
We'll go with it. Okay, and x goes to there. Okay, so we look at the circle. You've been given a circle, and you've been given a, you have to look at what you're given. You're given a secant, and you're given a tangent. Very good. You knew it. So then we look, we say, okay, if you're given a secant, you're given a tangent, which theorem are you going to be applying for this case? Yeah, 916, and then you say, okay, well, what is that theorem? The theorem states that the tangent squared is equal to the product of the secant times its exterior. Well, what's our tangent in this case? The tangent is x, so x squared equals the product means 2 things, right, multiplied, of what? 8? 20.
Root 20.
Root 29. Okay, it's the product of 2 things. What are the 2 things? Maybe don't say the product yet. What are the...
5 times 4.
No, not 5 times 4. It is 9 times 4. Because it is what? It is the secant segment, AD. So what's the secant segment here? Not 5, not 4, but 9. So it is 9, right, for the whole thing, times the exterior. What's the exterior in this case? 4. So 9 times 4 is 36. So x squared is equal to 36. X is equal to 6. Why do I not say plus or minus? It won't be minus, right? We won't have a negative length. So sometimes we can use the negative one, but not in this case. All right, let's go to number 2 here. And let's say we have, okay, circle here, and then we have secant there, and then that's 10 right there. That is x right there, and then this is 8 and 4. 8 and 4. Okay. We are given a circle, and we are given, what are we given? Tangents, chords, secants.
2 secants.
2 secants, very good. And are we talking about angle measures? No. So if you're talking about angle measures, you have to go back to 9-5 or something, or 9-6 when we were talking about angle measures. We're not, we're talking about lengths, so we're going to go to 9-15. What are the lengths? Okay, or what's the equation we can write? Right? So in this, it was this. The secant length times its exterior is equal to the secant length times its exterior. So we just set up that equation. What's the secant length on, let's go with the top one. What's the secant length on the top one? X, yeah. So we're going to say x times x minus 10. Where'd you get x minus 10 from?
The difference of it.
Yeah. Yeah, exactly right. The difference of, okay, the whole length minus this length gives you this length right here. So x minus 10 would be that length right there. Equals, what does it equal? 12 times 8. Where'd you get the 12 from? Well, it's the whole length, so 12 times 8. All right. How do we go about solving this one?
Accurate.
Well, it's already factored there.
Do it in and then factor it.
Do it in and then okay, so x squared minus 10x equals, what's 12 times 8?
96.
96.
And then subtract over.
Subtract over. 96 is equal to 0. This is a polynomial equation because it's got the squared in it. Whenever you see a squared in it, you have to think polynomial. And you got to think, oh, I might need to factor or quadratic formula. One of those two. Is this one factorable?
Yes.
I think it is. What does it factor out to be?
6 and 16.
So x and x, and then 6 and 16.
Yeah.
Very good. And then, which one's which?
Positive
Plus
and negative.
6.
Positive, negative. Therefore, x is equal to negative 6 or 16. We double check it. Which one doesn't make any sense? Negative 6 doesn't make any sense for this, so 16 works for us. If that's a challenge for you because of the factoring, you have to go back and review factoring. Okay? All right, let's do 3. Third one, and we'll go center there, and then we'll go out to here, 10, and where is this segment here? There, that forms a 90. That little section is 4, that section is x. Okay, what do we have here? A chord. How many chords?
1.
1 and a radius.
Well,
In diameter.
Is the diameter a chord?
Oh,
You bet. So you have 2 chords and then a radius. Yeah, so in this case, we're probably going to land on which theorem? 914, right? 2 chords. All right, so we have 2 chords and a radius. All right. So we're not going to pay attention to these ones, 915 and 916. We're going to look at 914. 914 states for us that segment times segment equals segment times segment. So I need to find the segments of the chords. Yeah, very good. All right. Now this is the center. I didn't state that, but that's the center. Okay.
Hold up, buddy.
Yeah, I'm going to give you a minute to think. Some of you are tracking with it.
should put that one
We should.
By the way, that 4 again applies to here. The X applies to here, so the 4 is from here out to
in.
there.
Not very.
How would you do that? Small.
Oh, can we take out
16. Wait, no. Because it would be 16 times 4 is equal to x times x.
Okay, what's the piece of information that's necessary for us, but it doesn't match right here?
X.
oh,
16 times 4 is equal to x squared.
The what?
the 10 is the radius.
10 is the radius. So something that gets people confused is they're looking at, like, it's not excess information, it's necessary information, but if you erased it, now you're looking at a chord and a chord. It's like, oh, okay, that's easier. But if I erase it, the purpose of having it in there was to say that the radius was 10. So what part can I make 10?
Oh, you're right.
Yeah. Make the line for your will.
That is 10. right?
And
This is a radius.
the other side is 6.
This part would be 6 right there. Okay. So, in other words, this is 10 and this is 10. Okay. But now I need to figure out, the theorem states segment times segment. So let's look at that first one we were just looking at. Segment is 10. What's the segment here? 10 equals, now remember, segment times segment. Segment times segment.
Wouldn't it be 16 times 4? Because
Yeah.
it intersects.
Yeah.
Oh, thank you, not 10 times 10.
You just gave Nicholas false hope.
Dang it.
I gave Nicholas also.
Yes.
Thank you, 16 times 4. Because yes, that segment to right there is 16. Thanks for catching my error. And then
No,
this
Mr.
segment
Austin.
right here is equal to 4. So yes, 16 times 4 equals, why is it x times x? I only see this x.
Because
the other
the diameter splits it in half.
Yes, if it intersects at a 90, that's another rule from the beginning of chapter 9, it makes this congruent to that. So this is x, then that is x. So x squared is equal to
So I was right.
64.
64. Z, your backpack. Turn yourself around.
My bad.
That's okay. There you go. Nice. Thank you. So it'll just be a little shake in the camera. 64. And what does x equal? 8. And we're not worried about the negative part. We're only worried about the positive part in that case. Okay, let's stop there. Have you get started. Yes, don't forget a lot of review from chapter 9. So hopefully you can gather the information for tomorrow's Jeopardy review and then for the test on Wednesday.